Good morning, my dear students. Welcome in Strength of Materials. We are in a simple stresses and strain, chapter number 1. So, we saw load. Now we are in types of load. So, we know tensile load, compressive load, shear load. Now, my dear students, today we are going to switch on direct load. This is again the fourth type of our types of load. We have a tensile load, we have a compressive load, we have a shear load. Now, fourth type of load is what? Direct load. So, my dear students, in tensile load, the forces which are moving away from the body, in a compressive load, the forces which are moving towards the body, in shear load, the forces passing by touching to the surface of that body. It means the forces tangential to the surfaces of that body, area of the body. So that is what shear load. Now, so today we're going to switch on direct load. So what is direct load? So direct load is nothing but the load whose line of action is coincide with the axis of part. Part means very well element, and each and every part or element very well having shape, area, or we can say having what? Sides. So each and every shape, each and every area, each and every part or each and every element having axis, centroid, we can call it. So whatever the force going to act on that part, that force acting at the center, acting at the centroid, acting at the axis, acting at the center of that part element of a body. So when forces acting on the part at the center, at the centroid of the part, is called as direct load. It is very simple. So that force may be tensile force, that force may be compressive force, but that force must be acting at the center of that part. That force must be acting at the centroid of that part. So when that force is coinciding at the center, coincide at the axis, that phenomena is called as direct load. So we have a machine, in that machine having number of parts. Each and every part has got axis. So that axis loaded at centrally, the axis loaded by direct load. So that is what direct load. So what is direct load, my dear students? Direct load means the force, the load which act at the center of that part. It means the line of action of force is coincide with the axis of the part. Coincide means your action of force, direction of force, or force exactly at the what? Axis. On the what? Axis. So when force acting on the axis, when force acting at axis, that is called as what? Coincide. So action of force is coincide with the axis of part. It's called as direct load. That force may be compressive or that force may be tensile. So whatever the type of force is there, but that force must be coincide to the axis of the part, must be lie on the axis of the part, must be acted at the center of that part. It's called as direct load. It means centrally acting load on the part is called as a direct load. Those loads acting at the centroid, those load of action or line of load of action is located acting at the center of the part is called as what? Direct load. So see, my dear students, next type of load is what? Eccentric load. So this is the last load I have with us. See, so eccentric load means the load whose line of action does not coincide with the axis of element. It means it is exactly opposite to the what? Direct load. Eccentric load is opposite to the what? Direct load. See, we have a part in the first figure. See, first figure have with us one a blue shading rectangular area. Have with us that area is supposed to be as one body, and that area having what? One axis. Each and every area having axis. Each and every part or element having axis at the centrally. We can call it centroid. So see, we have a L. It means length of that part. Diagram number 1. I'm telling you diagram number 1. So apart from that axis, apart from some distance, apart from some axis, we have one force towards the part from top side. So see, in between that force and axis having some gap, having some span, having some distance, that distance is called as eccentricity. That distance is called as what? Eccentricity. That span is called as what? Eccentricity. So span, distance, gap in between axis and force. So action of force, some where they have act in which having what? Distance. In which means in between means in between axis and force. In between having what? Some span. In between having what? Some distance. So that distance showing eccentricity. It means here, whatever the force they are going to act, that force never going to coincide, never going to act on the axis. The force which acting away from the axis, away from the centroid. And away from the centroid means in between having some distance, in between having some gap. So the distance between what? Force and axis, that is also called as eccentric force. In between load and axis having some span, it is also called as eccentric load. It means on that part, the force going to act, but not exactly at the center, away from the center, apart from the center, some distance having that load from the center. So that phenomenon is called as what? Eccentric load. Eccentric load means the line of action of force was never going to coincide to the axis of that part. So the force which acting on the part but away from the axis, apart from the axis. So the span, gap, distance in between load and axis of that part is called as eccentric load. And what is direct load? Direct load means the load which is going to act at the center on the centroid of that part, that area. But what is eccentric load? Eccentric load means the load which acting on the part but away from the axis, acting at some distance from the axis. So that is what? Eccentric load. So see, second figure have with us, that is what? You know, the windmills. Everyone have seen that windmills. So see, the windmills having some blades, you know, the blades. That blades mounted on a rotor. See, at the top side having some blades. 3 blades are there, and that blades mounted on the one rotor, and that rotor again mounted on one column. So see the vertical column, supporting column, that column going to support to that rotor, and that rotor going to hold blades. See the weight of that blades, position of that blades, something distance is there in between blades and the supporting column of that windmill. So see the blades mounted on that rotor, and that blades having some distance from the supporting vertical column. So see the vertical column of that windmill and blades, rotating blades of that windmills in between having what? Span, in between having what? Distance. So in between rotor blades and in between vertical supporting column having what? Distance. So one end of that rotor, see the horizontal rotor on the top side of that vertical column. So horizontal rotor is there, and that one end of that vertical rotor taking support from the bottom side by the vertical column, and another end of that horizontal rotor loaded or mounted by blades. So see the blades, they are having 3 blades. So that blades holded by that rotor, but some away from the vertical column of that windmill. So in between rotor blades and vertical column of that windmill having some distance, having some gap. So that is called as eccentric load. So whatever the blades load coming on that rotor, that load we can call it what? Eccentric load. So the blades acting a load on that rotor, or blades acting a load on that vertical column directly in the manner of eccentric load. This condition is called eccentric load, because in between blades and vertical column, supporting vertical column, in between having got some distance, in between having got some gap, in between having got some span. So span in between rotor blades and vertical supporting column of a windmill, this is called as eccentric load. So this is the best example have with us of eccentric load. So see in the third figure we have a one cube vertical column in third figure. Then see at the top surface, so or which will find what on the top surface will find what? Force coming towards that surfaces from vertical side. From vertically we have what? Load on that column. Third figure, my dear students, see third figure. So in third figure, from top side, from top surface of that figure, cube column having one vertically downward force, and see the position of that force which is exactly away from the center of that part, and it is denoted by E for eccentricity, and apart from some distance, apart from center of that axis of the part, the load is there. It means the load which is acting away from the axis, and it is denoted by E, that span, that distance denoted by E, small letter E, and that E means E for eccentricity, eccentric load, because that load never going to match axis of the or center of that part. It means that force acting away from the axis of that part. It means some eccentric distance is there, and there we find what? Load. So my dear students, this is what? Eccentric load. Eccentric load means the load whose line of action does not coincide with the axis of element. So these are the types of load. It is very, very important. These are the load we are using to design our machine parts. We'll see later on how we can use it to design our parts, how we can use it to make our machine. We'll see later on. So these are some types of loads have with us, my dear students. Please keep in your mind. It is very, very important as far as our SOM or machine design is concerned. So we have seen what? Tensile load, compressive load, shear load, direct load, and eccentric load. So these are the 5 types of loads, basic loads. Time to time we'll find in our machine parts. Without this, our machine can never move. Our machine can never give output. Without this, we cannot design our machine. It means Keep in your mind, my dear students, tensile load, compressive load, shear load, direct load, and eccentric load. So what is tensile load? Tensile load means the forces, the load which are acting away from the body. Compressive means the forces which are acting towards the body. Shear means the forces acting tangentially to the body. What is direct load? Direct load means the forces which are going to, the load or forces which are going to coincide with the axis of the part. And what is eccentric load? The load which are never going to coincide axis of the part. Direct load means the force or the load which acting exactly on the center of the or centroid of the part. And eccentric means, the eccentric load means the load or force never going to acting on the center. It will always acting away from the center of that part. So this is what eccentric load. So tensile load, compressive load, shear load, direct load, and eccentric load. These are the 5 basic types of load have with us to design our machine part. So my dear students, if you have any doubt, so please call me, contact me. So thank you very much. Stay safe, stay home.